Okay, guys. Let's start with section 6.4, graphs of the sine and cosine functions. Okay. Now, before we start graphing sine and cosine, let's talk about what the 6 trigonometry functions are. So f of x, which is the same as y equals, we're going to start with the first one, sine of x. The next one, we're going to have f of x, which is the same as y equals, cosine of x. X is your input, f of x is your output. F of x, which is the same as y equals, tangent of x. The next one, the reciprocal of sine, is 1 over sine of x. It's just going to be cosecant of x. The reciprocal, which is 1 over cosine of x, which is the same as, I'm blanking out, secant of x. Okay, so, and this is going to be 1 over tangent, which is the same as sine of x divided by cosine of x, which is going to be cotangent of x. Excuse me. So these are the 6 awesome looking trigonometry functions, okay? Alright, so definitions. We got 2 vocabulary in front of us. The first one is some books will use period, and some books will use cycle. So a cycle or a period is going to be how far, that means in length, before the graph repeats. Okay. So let's give you 2 normal functions here. F of x equals a sine b of x. Okay, this is a vertical stretchal compression, and this is a horizontal stretchal compression. Or I can use f of x equals a cosine b of x. Okay, so a vertical and a horizontal change in for this particular function. A period or a cycle is going to be 2 pi, which is a full revolution, or divided by absolute value of b. Because we are talking about length or distance, how far it goes before it repeats, this has to be an absolute value because distance or length is not going to be negative. So let's talk about the amplitude. How high, okay, so the amplitude is how high or how low the graph goes from the center, okay? How high or how low the graph is from the center. Okay. So this is really a vertical distance, and this is a horizontal distance. And the formula for our amplitude, so amplitude, is simply absolute value of a. Because this is talking about a vertical distance, we're going to use the vertical change. Okay? And because it's distance, we're using absolute value, because absolute value is the distance from the center, or from 0, I meant. Moving on to our first. And if I'm going too fast, keep in mind that you can pause, right? That's an awesome, beautiful thing about video notes. So let's talk about the graph of the parent function, y equals f of x equals sine of x. So we are going to use the unit circle. So I'm going to quickly sketch out the unit circle here. Okay. And, oops, you can't see that. I'm going to make an input and output chart. Here's x, and this is y equals f of x, so I can either use y or I can use f of x. It doesn't really matter. And by now, you should have all the values of sine memorized, right? That was the whole point about the unit circle quiz. So the first value I'm going to use for my input is 0. Okay. So when x is 0, sine of 0, because this point is labeled 1 comma 0, sine of 0 is 1. For the purpose of demonstrating, I'm going to use pi over 6. So pi over 6, sine of pi over 6, it's opposite over hypotenuse. Opposite of this is going to be 1, hypotenuse is 2. So sine of pi over 6 is 1/2. Now the next one I'm going to use is pi over 4. Okay, so again, these are all the input values. Because we're graphing it for the very first time, I want you to see where it's supposed to be with all the values of the unit circle, or at least all the values on the first quadrant. So when the input is pi, oops, I meant pi over 4. When the input is pi over 4, sorry, I'm a little sick, so I'm going to be clearing my throat a little bit more than normal. So sine of pi over 4 is rad 2 over 2, okay, from memorization. And then the next one I'm going to do pi over 3. Sine of pi over 3 is going to be, if this is 1/2, this is rad 3 over 2. So that's the first quadrant. Then the next one I'm going to use is this one, pi over 2. Sine of pi over 2 is going to be, sine is going to be the y value because we're on the unit circle, so y value would be 1. Now, I could technically do multiples of 60, multiples of 45, multiples of 30, but I'm just going to pick the sorry, that was about to start 6th period. I'm just going to pick the quadrant angle, which is on the x-axis and y-axis here. So sine of pi, my next input is pi. Sine of pi, because sine is y for this one is going to be 0. And this is 3 pi over 2, so sine of 3 pi over 2. Y for this particular point is -1. And we're back to a full cycle, which is 2 pi. Sine of 2 pi, this is 0. So as you can tell, I am graphing. My inputs are starting from 0 and it ends at 2 pi. So here's 0 and here's 2 pi. And I'm going to go as far as 4 pi, okay, because I want to double it. And I want to go as left as -2 pi. I want to go to the left hand side of it. If you check this out, 1/2 is obviously 0.5. Now if I use my calculator and see where rad 2 divided by 2 is, so square root excuse me, square root of 2 divided by 2 gives me 0.71, so about 0.71. And I'm going to take my calculator and do square root of 3 divided by 2. That gives me 0.87. So this is about 0.87. The reason I'm doing this is I want you to see where it is when I graph it out, okay? Because this is the first time we're graphing it. That's why I'm kind of including these values. Excuse me while I drink some water. So the high is 1, okay, and my low is -1. I'm going to come in and divide this into 4 equal intervals. So first I'm going to split this up into halves and then halves again, so 4 equal intervals. If this is 2 pi, right in the middle of it would be pi. If this is pi, 1 tick mark is worth half of it, so pi over 2. So this is pi over 2, this is 2 pi over 2, which reduces down to a pi. This is 3 pi over 2, if I really want to write it, 3 pi over 2. I guess I'll write it, because it's the first time. 4 pi over 2 reduces down to 2 pi. And same thing for the next one. First, make it into 2 equal parts. Then do it again. So now each 2 pi is going to get 4 equal intervals. Between 2 pi and 4 pi, I'm just going to label that 2, 3 pi. Similarly to this, I want you to make into 4 equal intervals. Between -2 pi and a 0 is -pi. Okay, and this is a -pi over 2. Now each tick mark has to be worth the same amount. You can't say this is a pi over 2 and all of a sudden this is 3 pi over 2, because then this distance here is only half a pi and this distance here is a full pi if you jump from pi over 2 to 3 pi over 2. So make sure each tick mark is equally labeled. And you don't have to label every single tick mark. Just a couple of these will be good. So first, when x is 0, y is... Oh, dude, I completely did this wrong. When x is 0, y is 0. Oh my goodness. I'm so sorry. I'm looking at the 0 right here. So when x is 0, y is 0. I hope you caught that before. My bad. Okay, so when x is 0, y is 0. When x is pi over 6, y is 1/2. Now, where would that be for pi over 6? If this is a pi over 2, half of that would be pi over 4. So pi over 6 would even be smaller, okay? So pi over 6 would be a third of the way. So I'm going to go about a third of the way and go up to a half. So this is where half is, okay? So output is a half, input is a pi over 6. As pi over 4 is exactly half between 0 and pi over 2. So at pi over 4, I'm going to go up about 0.71. So slightly bigger than that, okay? At pi over 3, I'm getting closer, right? At pi over 3. Now this is pi over 2. So at pi over 3, it would be closer to pi over 2. I'm going to go to 0.8. So I'm kind of creeping up to 1 there. Then at pi over 2, I have exactly y is 1. Okay. So check out those dots. They're really close to each other, but as you know, they're approaching my highest value, which is 1. Then the next one I have is going to be pi. When x is pi, y is 0. When x is 3 pi over 2, which is this piece, y is negative 1. When x is 2 pi, y is back at 0. So this is sort of my curve, right? Check that out. Isn't that beautiful? This is what a sine curve looks like. And I'm just going to repeat this pattern, okay? So if I'm starting at 0 and I'm ending at 0, the next tick mark over, so check this out, which is a pi over 2, which is one more over here, which is going to be 2.5, which is really 5 over 2 pi. So at 2.5 pi or 5 pi over 2, if I'm going and looking at the pattern, because that's what math is, I'm going to go up at positive 1. Then 2 tick marks over, I'm coming back at 0. Then 3 tick marks over, then I'm going to go down at negative 1. Then the last tick mark, I'm back at 0. Okay, so this is repeating. This is still the same sine curve, just repeating. Okay? And because I can go up again, so I'm going to put an arrow that's kind of going upwards on this end. Now repeating this over here. I'm starting at 0, so if I pick a 0 point here, if you can look at this, 1 tick mark to the left of this 0, I'm going down. So that's what I'm going to do, go down to negative 1. Okay, so these two tick marks to the left, I'm staying at 0, so that's going to be at 0. 3 tick marks to the left, I'm going back up at 1. And repeating myself, so this means I'm staying back at 0. So this is graphing 2 positive intervals and 1 negative interval, okay? So if you look at this, notice how I'm kind of repeating myself here. And then if I go again, it looks exactly the same as this. So this is what's called a period. See how this period right here? This is called a period. How far did I go before it repeats? So I've gone a distance of 2 pi. So that's what the period is. Period is 2 pi. Because by formula earlier, I'm always going to take 2 pi divided by absolute value of b. But if I were to insert 1 here, and 1 in front of x is really absolute value of 1. Well, as you know, 2 pi divided by 1 is going to be 2 pi. So that's why your period is 2 pi. Now let's talk about the amplitude, what it is. From the center, so here's the center, okay? How high did we go up and how low did we go down? We went up 1 unit and go down 1 unit. So the amplitude is going to be absolute value of A. Well, A is going to be in the front. Well, I have 1 in the front. So absolute value of 1 is just going to be 1, which matches our graph. Okay. So your algebraic has to match whatever you are graphing. And please go back and fix this. That was an awful, awful mistake. So properties of sine function. the domain, it goes on forever. Just because we stop at 3 periods doesn't mean the function itself stops. So the domain is going to be from negative infinity to positive infinity. The range, how high and how low? We're going from negative 1 all the way to positive 1. We have nothing above 1 and nothing below negative 1. So the range is inclusive from negative 1 to 1, and we want to write the smaller value first. Symmetrical. Is it symmetrical about the origin, which is odd? Is it symmetrical about the y-axis, which is called even? Okay, so symmetrical about, it's definitely not the y-axis, because as you can look at it, if I fold it on the y-axis, the left and the right is not identical. But if I pick a value on the right, so if I were to do algebraically, f of pi over 2, does it equals to, I'm sorry, f of negative pi over 2 by formula f of negative x, does it equal to negative f of x? Okay. So if I put in a pi over 2 and I multiply by negative 1, is it going to equal to this? That is really the question. Okay, algebraically. You can look at it and it looks odd, but algebraic, let's prove it. So sine of a negative pi over 2. Well, here's negative pi over 2, right? Negative pi over 2 over here is negative 1. Awesome. Negative 1. Question mark, is it going to equal to negative 1 times whatever this output is? Well, sine of pi over 2. Well, here's pi over 2. Sine of pi over 2, from my graph, it looks like I have 1. So is negative 1 equal to negative 1? And the answer is yes. So therefore, I can check some more points, but we can see that this is an odd function, okay? Which is f of negative x equals to negative x. Period, we said the period for the parent function is going to be 2 pi. X-intercept. Okay, let's do the y-intercept first because it's quite easy. Y-intercept, there's only one dot and only one dot, which is 0, 0. We'll do the max and the min. Actually, you know, we'll do the x-intercept as well. Okay, so the x-intercept is an interesting concept. And we have to list all of the x-intercepts. Okay, so if you look at it, I have multiple x-intercept. One is at negative pi, one is negative 2 pi, and it keeps on going forever. One's at pi, 2 pi, 3 pi, 4 pi. So let's talk about how would I write all of the x-intercepts. Okay, x-intercept. Okay, so the pattern is negative pi, 0, pi, 2 pi, 3 pi, 4 pi, dot, 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 and dot, dot, dot on the left as well. So if you look at the pattern, would you agree that I will start at 0. I can add a pi each time, but that would be hard to say. So we're going to come up with an algebraic expression to kind of summarizes where all the x-intercepts are. I'm going to start with pi, and every time I'm going to multiply by, let's just say, k. And, well, what on earth is k? Well, k can be any integer, right? K can be 0. Integers are numbers that are negative or positive whole numbers, including 0. So I can say, hey, the x-intercept is pi k, where k is any integer. And that will work. I can put in negative 5, and I'm pretty sure if I keep on graphing, I'm going to have an x-intercept there. So this is one example of that. And yes, you do need to tell me what k is, where k is any integer. Okay. Now the question, is this the only way to write your x-intercept? No. It's more. You can also go k plus, okay, k plus, you can do pi plus pi k, or you can do multiple ways, okay? You can be creative as long as you test it and it works for every single one of your x-intercepts. All right, maximum. Looks like I have my maximum, okay, my maximum at, look at this one. The maximum is 1 at, okay, the maximum is 1 at. Well, locations are, let's talk about this one. Pi over 2, 3 pi over 2. And there's another one over here, okay, so 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. So the first one is going to be pi over 2. Another max one is 5 pi over 2. Okay, max means what's the highest r. And if I count negative pi over 2, negative 2 pi over 2, negative 3 pi over 2, negative 3 pi over 2 over on the other side. And I'm pretty sure if I keep counting, I'm going to go up here at some point. So 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2. So 9 pi over 2 is sort of, and dot, 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 or dot, 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 okay? So check out this pattern. The smallest one I can see is pi over 2, right? And the negative is going to be negative 3 pi over 2. So on the positive side, the smallest maximum is when x is at pi over 2. Looks like I'm adding 4 pi over 2, don't you see? So this is 4 pi over 2. Well, isn't 4 pi over 2 a full cycle of 2 pi? So it looks like I can start at a pi over 2. Okay, so I'm going to take a pi over 2. And if I add a full cycle, looks like I can get the next one. Let's test it out. And then I'm going to multiply by k. So when k is 0, if k is 0, I would have this whole thing is 0, so my first maximum is at pi over 2. When k is 1, then I'm adding a full cycle, which is 4 pi over 2, which is 5 pi over 2. How about when k is negative 1? If it's a negative 1, I'm subtracting 2 pi, which is really subtracting 4 pi over 2. So a pi over 2 subtract 4 pi over 2, I'm going to end up with negative 3 pi over 2. How about when k is 2? 2 times 2 is 4. If it's 4 pi, that's really 8 pi over 2. Well, 8 pi over 2 plus a pi over 2 ends up with 9 pi over 2. So this works, right? So k is any integer as well. So my max is at 1. My max is 1 at pi over 2 plus 2 pi k, where k is any integer. Okay? This is so difficult and so hard to understand that, remember, you need to repeat this video, okay? If you didn't understand how I came up with the X-intercept equation or formula, or how I obtained all the maximum locations for all the locations for the maximum. Similarly to the minimum. The minimum, the first one looks like the lowest point is at 3 pi over 2. Okay, so let's write minimum right here, the little space that I have left. Minimum, it's at negative 1. I'm sorry. Minimum is negative 1. Minimum is negative 1 at x equals. The first one is positive 3 pi over 2. Looks like 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. 7 pi over 2. And if I were to go this direction, that's negative pi over 2. So go this side, negative pi over 2. And I'm just going to go dot, dot, dot on the left and dot, dot, dot on the right. Okay. This is getting very busy in here. So let's draw some lines so we can see. And how about let's draw some line for the x-intercept so we can see. When it gets so busy, okay, and when you're struggling and you're trying to look back, you're not going to know what happened unless you are kind of trying to make it clear or clean or organized at this point. So would you agree that from 3 pi over 2, if I were to add 4 pi over 2, I would get to 7 pi over 2. 4 pi over 2, reduce that down to 2 pi. So this is very similar to my maximum. I would say, hey, max is negative 1 at x equals 2. I'm going to start with my first small positive here. 3 pi over 2 plus 2 pi k, where k is any integer again. Okay. So when k is 0, I would end up 3 pi over 2. Check. When k is 1, that means I'm adding a full revolution, which is 2 pi. A full revolution converted out to a denominator 2 is 4 pi. So 3 pi over 2 plus 4 pi over 2, 7 pi over 2. Check. How about when k is negative 1? That means I'm subtracting. So 3 pi over 2 subtract 4 pi over 2 is a negative pi over 2. Check. So all of that works. So minimum is negative 1 at 3 pi over 2 plus 2 pi k, and where k is any integer. Oh, I'm trying to squeeze. Okay. I'm really sorry. This bothers me a lot to where it's not very neat, but try your best and try to make it organized. And this is the end of today's notes.